favorite things. Donut. Yeah, that donut tastes really good, but have you ever wondered how much energy is in that little donut?
I never want to lock you down. I know you're not mine, it's just my turn, but we can still have fun for now. You told me you don't really do commitment, trust me, consider your message received. When you said you couldn't take us too seriously, I must admit I was relieved. Cause I never wanna play happy families with you, but I like having you around.
So class, here we are back again in the laboratory. We're going to do a lab today on cellular respiration again, how much energy is in a food and what our body uses that energy for. We call this lab the Calorie Lab, or how many calories in a food, because calories are a measurement of how much energy is in a food. For this experiment, or this lab, we're going to need a calorimeter. Just made it out of a tin can right there. We just poked some holes in. We got a couple of 80 milliliter beakers. Okay. We've got a large graduated cylinder, 100 milliliter graduated cylinder. We've got a thermometer. We have a little piece of aluminum foil here, and we have a little paper clip that's been bent into a shape that's going to hold our sample on it. We have an electronic scale and some honey puffed wheat. That's always good. And we've got some peanuts. In our experiment here, we want exactly 50 milliliters of water. Now remember, we measure at the meniscus, and you can see that's not quite at 50 milliliters, so we're going to have to adjust this till it's exactly, we have to put a few drops in. Now, we want exactly 50 milliliters because we're going to be doing a comparison of two different kinds of foods, the honey puffed wheat and the peanuts. And so we want exactly 50 milliliters on each one. We've got this as close to 50 milliliters as we can get it. Another thing we want to be as exact on is the weight of our food sample. So we have just a peanut here. We're going to drop it on our electronic scale. And you'll see it weighs 7.1 grams. So we're going to take a scalpel and we're going to carve off just a little bit of the peanut and get it down to 7 or exactly 5.5 grams. Exactly 0.5 grams. That will help us in our experiment. So we're going to set the peanut aside and we're going to weigh out 0.5 grams of our honey puffed wheats, okay? And so we're just going to put on there and we will get 0.5 grams. So we're going to put one more little piece on there. 0.5 grams of our honey puffed wheat. Okay, now, so we have our peanut, 0.5 gram of peanut, and 0.5 grams of the honey puffed wheat. Which one of them do you think has the most energy in it that our body could use? The peanut or the honey puffed wheat? Okay, for this experiment, we're going to need a table to do some recording on. And this is in your lab instructions. We're going to make a table like this right here to record our data on. Our instructions start out on the procedure. Using a graduated cylinder, obtain 50 milliliters of water and carefully pour it into the beaker. Determine the mass or the weight of the water and record your findings on the data table. Okay. To get exactly 50 grams of water, we take a clean, dry beaker, set it on the scale, push the tare button, it goes to 0. Now we take our graduated cylinder, which we think has 50 milliliters of water in it. We pour it into our beaker. And you see it's not exactly 50 milliliters of water. So we're going to have to add a few drops. And another drop. Can one more drop do it? 50.2. So we're just going to put our dropper in and take it out. 50.0 grams of water. So we're going to take that and set it aside and see what's next on our instructions. We're supposed to bend our paper clip like this so that it can, and we're going to put our food sample on it and we're going to weigh them both, okay? So we'll do the peanut first. So we have our scale, we push the tare button to 0 our scale. And we have the peanut, which we know weighed 0.5 grams, and our paper clip. I'm going to set it on the scale, and it weighs 0.89 grams. Okay, our instructions say to record the mass of the water, which was 50.0 grams, and the initial mass of the food sample and the paper clip. This would be the peanut and the paper clip, 0.89 grams. Okay, so you notice that I cut this out of the instructions, but see right here, it wouldn't fit on the page, so I cut out this part in the middle so that it would fit on the page better. And the instructions asked us for the initial temperature of the water, which was 24.5 degrees Celsius. So we just took the thermometer and we placed it in our beaker of water and we took the temperature of the water, okay? Okay, now we're kind of ready to get started here. Our instructions say place a small piece of aluminum foil, we got that right here, on our lab table. And we're going to take our piece of food sample, which is the peanut, on the paper clip, and we're going to set it right on here. The paper clip really works well for this because we can bend it and make it balance, okay? Now the instructions say place a piece of aluminum foil underneath it, adjust the paper clip, which we did, place the thermometer inside our beaker like this, okay, and set it so the bottom of the beaker is about 4 centimeters, right about that far above our food sample, okay? Now our instructions say, carefully light the food sample with a match and quickly place our calorimeter over the top of it. So we would expect this to burn and the water temperature would go up. And the change in the water temperature is going to be an indication of how much energy is in our food sample. So we take our match, we light our peanut, and as soon as the peanut gets going, we put our beaker on top. There it goes. And we're going to watch it till our fire goes out, and we're going to check the new temperature. You can see from the glow inside the beaker that it's still burning down inside there. A little something you have to keep in mind. If your food sample goes out, like if the peanut goes out, you just take the calorimeter off and relight it, but put it back on as soon as you can. You can see we have quite a little fire going down in there now. And we're going to keep checking the temperature of the water by looking at the thermometer right here, and it's up to 34, almost 35 degrees Celsius. We want to catch it at its highest temperature. Now you will notice we have some smoke coming out around here, and the idea is to capture as much of the heat as we can. This is a relatively crude calorimeter. However, we're going to see a definite change in the temperature. It's almost up to 50 degrees Celsius right now, and our little peanut is still burning. Our peanut just went out, but the temperature will keep going up. So we want to monitor the temperature, keep our eye on the temperature. It's up to 54.5 degrees Celsius. Is it going to make 55? Okay, so the temperature is going back down. It went up to 54.5 degrees Celsius, and it's gone back down already. It's dropping rapidly, okay? We're going to let that cool off for a minute, and we're going to record the change in the water temperature. So it went up to 54.5 degrees Celsius, okay? Now, if you remember, our peanut and the paper clip weighed 0.89 grams. So we're going to reweigh it. We're going to take it, we let it cool off. We're going to set it right up on there on our scale. Now it weighs 0.43 grams. Quite a change there. And we're going to record that in our book right here, our lab book. So the mass change of the food sample and the paper clip. Okay. So the mass change is, it was 0.89 grams. The final check, it was 0.43 grams. The change is 0.46. Now here's a little something you can learn. When we write the change of something, we write this, it looks like a triangle, but that's called delta. Like you've seen the movie Delta Force, they have a triangle. A triangle like this in science means the change of. So this was the change of the mass of the food sample in the paper clip, delta 0.46. Now the instructions say to repeat our procedure and see if we get the same results. So let's do that. We've got another peanut. You can see it weighs 0.52 grams. You have to take a little bit off. Exactly 0.50 grams of our peanut sample. We're going to set it on the scale with our paper clip. And weigh it again. It weighs, this time, 0.87 grams, and we're going to record that in our lab book. You can see we're very close. We just need a tiny drop. .501. We're just going to take our dropper, empty dropper, put it in, take out a tiny bit, and we have 5.0 grams of water. Set that aside. Lab book, on sample number 2, we write the mass of the water is 50.0. The initial food mass and the paper clip was 0.87. And the temperature of the water, the beginning temperature of the water this time is exactly 25 degrees Celsius. So it's 25.0. We're going to repeat the procedure. We have our little peanut right here. We're going to light it and immediately put our calorimeter back over the top of it. Set this on top, and we're going to record the change in the water as it goes up. Again, you can see the flame down inside the calorimeter, and the water temperature is almost up to 30 degrees Celsius already. We'll keep our eye on it. Still burning, getting a lot of soot. You can see down here in the bottom, you can see the flame is still going. It's up to 44 degrees Celsius. Our peanut went out and the temperature got up to 48 degrees Celsius. So we're going to set our calorimeter aside. We're going to write down a recording in our lab book that the final water temperature was 49 degrees Celsius. It went up one more degree. What is delta T, or the change in the temperature? We take 49.0 minus 25.0. See that the change in the temperature for the first time was 30 degrees Celsius and the second time it was 24. So a difference of 6. That's a big spread. So we're going to do this the third time. If we'd gotten within 1 degree, the same here, on sample 1 and sample 2, we wouldn't have to do the third trial. We want to get the difference in the mass of the burned food sample and the paper clip, and it's now 0.44 grams. So we're going to record that in our lab book. The change in the temperature, or the change in the mass, would be 0.87 minus 0.44. So you can see, even though we had a wide spread in the temperature, the change in the mass was about the same. So the change in the mass of the food sample on this time is 0.43. Delta 0.43. That's on the second trial. Okay, so we're going to do it the third time. The first trial, the change in the mass of the food was 0.46. The change in the second mass was 0.43. Almost the same, just 3/100ths difference on the mass change. Okay, this is trial number 3, and you notice that the peanut's a little heavy, 0.55 grams. We're going to have to trim some off. 0.51, so just take off a tiny bit more. So now our peanut sample, the third sample, is 0.50. It's floating up and down because I'm talking here and it's affecting our scale. Okay, we weigh the peanut for the third time with the paper clip, and it's 0.88 grams. We're going to record that on our lab book. Okay, we put our clean beaker on the scale. We push the tare button and we add 50 grams of water, 5.0. You can see we've got a little bit extra water in here, so let's take our dropper, suck some out. Suck a little bit more up. Oh, got too much. Put a drop back in, drop back in, drop back in. One more little tiny drop. .01. Take our empty dropper, stick it in. It's going to take a little tiny drop. 50.01, 50.0 grams of water. Okay, we take our initial reading of the water temperature. It's 25.0 degrees. I'm going to call that 25.5 degrees Celsius. So in our lab book, what did we write? Sample number 3, we had 50 grams of water, 0.89 grams of the food sample and the paper clip, and the initial temperature, the starting temperature of the water was 25.5 degrees Celsius. Now, we burn it and we get these other two numbers here, the change. So we're ready for our third sample to be burned, so we strike our match. Get this peanut going. Quickly set our calorimeter on top and record the change in the water temperature. You can see it, the glow of the fire down inside there. It's burning quite well. It's giving off heat, a little smoke coming off. Temperature is up to 30 degrees Celsius. Still burning away, we're up to 45 degrees Celsius. Okay, our fire went out. It's at 50 degrees Celsius right now, 50.5. And we'll see if it goes up anymore, if it starts back down. So our temperature, the highest temperature on the third set was 50.5. So we need to find the delta T and also the change in the mass, the delta mass. So for the change in the mass, we take our little clip and the burned peanut and we zero the scale, we set it on there, and it is 0.43. So in our lab book, right here, we write down the third sample. Whoops, I didn't write down the final water temperature was 50.5. We need to add that in here. But the delta change of the mass was 0.45. So the first sample was our best. It was 0.46. The second was 0.43. The third one was 0.45, almost the same as the first one. Now we have some questions to answer here. Question number 1 says, determine the mass of food that actually burned. So that would be this right here. The change in the weight, the change in the mass. Now we have 3 different numbers, so we're going to find the average for that. We have a 46 for a high, a 43 for a low, and a 45. It looks like the average is going to be about 44.5 or something like that. So let's figure that out. We take 0.46 plus 0.43 plus 0.45 equals, and we'll divide it by 3. So we just took 0.46 plus 0.43 plus 0.45, that equals 1.34 divided by 3. It actually equaled 4.5666. So we rounded it off to 5. Okay. So the average change of mass was 0.45. So in our lab book, we write 0.45 is the average because it came out to 0.446. We rounded it out to 4.5. So answer for question number 1, what is the change in the mass, the final change in the mass? 0.45 grams. Question number 2 asks, it says, determine the change in the water temperature, the delta T. Okay, so all we do is we add up the 3 water temperatures. The change in the water temperatures were 30 degrees, 24 degrees, and 25. We add those 3 together, it comes out to 79. We divide it by 3, and it comes out to 26.3 degrees. That's how much the water temperature changed in the average of the 3 tests. Question number 3 asks, calculate the energy in calories that are in our food sample, the peanut. To do this, we take the change in the temperature, delta T, change in the temperature, delta T times the mass of the water. The change in the temperature, it went up on the average of 26.3 degrees Celsius times 50 equals 1,315. Remember our little honey puffed wheat or wheat puffs? Which has more energy, do you think? The peanut or the sugar-coated honey puffed wheat? Let's figure that out. Remember, we weigh the food sample and the paper clip. It came out to 80.87 grams or 0.86. My breath is making it move. 0.87 grams. We take 50 grams of water just like we did before. We take the water temperature, which is 25 degrees Celsius, just like almost the same as was on the other one. We light our sample. And we put our calorimeter on top quickly. And we monitor the temperature. And it is still burning. And the temperature is up to 30.5. And our fire just went out. Went up to 31 degrees Celsius. Calorimeter off, I noticed that there was still some unburned honey puffed wheats, so we lit them again, and the temperature has gone up to 33.5 degrees Celsius. Now it's up to 34. So 34 degrees Celsius. Okay, we're going to zero our scale. We're going to take our little burned food sample of honey puffed wheat. Very carefully, we're going to set it right on there. And we're going to see it says 0.49 grams. So for number 5, the change in the mass of the peanut was 0.38. Okay? 0.38. The change in the temperature was 25 degrees Celsius, and it went up to 30. It went up to 33 degrees. So that's going to be 0. That's going to be 8. So the change in temperature, delta 8. Delta 8 on number 5, the change in the temperature of the honey puffed wheat was delta 18 degrees. Now we have to put that into our formula to see how many calories are in it. So we do our little formula. The change in the temperature, which was 18, times the number of grams, the mass of the water, 18 times 50 comes up to 900 calories. So you can see that the honey puffed wheat, even though it's got a lot of energy in it, doesn't have nearly as much as the peanuts. Now we could do this 3 more times, and I know you'd be probably fascinated to watch us do that 3 more times, but our results would be pretty close to that. Just like the results for this one would have been pretty close if we'd only done it 1 time. This might have been 1,400, it might have been 1,320. This down here might be 910, it might be even 1,000, but it's going to be substantially less than the calories that are found in the peanut. Now you have to be thinking about why the amount of calories or energy in the peanut would be greater than in the honey puffed wheat. And to come up with that idea, why you think that would be, on your lab you have the nutrition label for peanuts and the nutrition label for the honey nut puffed wheats. It tells you what's in it. And this will help you figure out question number 6. Why does the peanuts have more energy in them than the honey puffed wheat? And you have to think about the 4 macromolecules we studied and which ones do what. You have to remember that. Okay, here's the data we got in case you didn't get it. The mass of the water each time was 50 grams. The initial mass of the food in the sample of the paper clip, the first sample was 0.89, second 0.87, the third one 0.88, almost the same, very close. The average would have been 0.88. The initial water temperature was 24.5. The second one was 25.0, and the third one was 25.5, almost the same. The average would have been 25. The final water temperature, we had 54.5, 49.0, and 50.5. And we figured out the average there was, the average change in the temperature was 26.3. The average change in the mass was 0.45. Now, it's interesting. If the mass changes, the mass of the food sample went from the average of 0.88 to an average of 0.45. Where did it go? Where did the weight go? That's a good question. That would be question number 7. The final mass of the food substances was 0.46, 0.43, 0.45. Question number 1 was, what was the average water temperature change? It was 0.45 grams. That was the change in the weight, excuse me. The average change in the mass, number 1, was 0.45 grams. Number 2 was, what was the average change in the temperature? It was 26.3. Number 3 also, we figured out the calorimeter, the calories in the peanut. We took the 26.3 times 50 grams of water, and we got 1,315 calories. The honey puffed wheat, we took the change in the temperature, delta T, times 50 grams of water, and it came out to 900. Number 6 question is, why does the peanut have more energy than the honey puffed wheat? Think of the macromolecules. Think of what each type of macromolecules do. Read the label for the peanuts and for the honey puffed wheat. And number 7 is going to be, where did the mass go? What happened to the mass? Number 7, where did the weight go? The weight was reduced by a lot. On the peanut, 0.45 grams. On the honey puffed wheat, it was 0.38 grams that were lost. What happened to the mass? Where did it go? Look at the formula. Learn this formula. This is the chemical formula for respiration. C6H12O6, that's our glucose. Plus 6O2, that's our oxygen. Yields 6 CO2, 6 molecules of carbon dioxide, plus 6 molecules of water, plus energy released. You have to think of this, if you think of this chemical formula, It will help you figure out what happened to the mass. Well, that's Keith Smith, science teacher extraordinaire, with our Calorie Lab, using a calorimeter, all our different apparatus, using our electronic scale. It was a lot of fun to do. Didn't make too many mistakes doing it, but good to see you again, and work on those questions.